Okay, so I'm going to prove the sum formulas for sines and cosines. So for any alpha and beta in R, the following are true. Sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta, and cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. We're going to let PQ be perpendicular to OQ, so PQ perpendicular to OQ. We're going to let AQ be perpendicular to OA. We're going to let PB be perpendicular to OA. And we drew R on PB so that QR here is parallel to OA. All right, so as you can probably see, we know that RQAB is a rectangle, right? And we're going to show that very easily. So we know the sum of the interior angles of a quadrilateral is 360. Okay, so we have the measure of angle RBA is equal to the measure of angle BAQ, which is equal to the measure of angle BRQ. And all these are equal to 90, right? All these guys are equal to 90. This implies, of course, that the measure of angle RQA is also equal to 90. So this guy here is 90. Okay, so we're going to use a theorem which states if we have opposite angles of a quadrilateral, if they're equal, that means that we're dealing with a parallelogram. So since all of them are 90, of course, this implies, right, that RQAB is a parallelogram, right? But of course, since they're all 90, it's more than just a parallelogram. We can just say that this is a rectangle, right? Okay. So now we know that RQAB, of course, is a rectangle. So now we're going to look at sine of alpha plus beta. So that means we're going to look at triangle PBO, right? So let me go ahead and scoot this down. So we know sine of alpha plus beta is going to be PB equals, of course, equals PB over, so PB over OP, right? Okay, we could split PB into two parts. We can say PB is equal to PR plus RB over OP. And then, of course, instead of using RB, we can use QA because we know this is a rectangle, right? So the same thing as PR plus AQ all over OP. Let's also look at what cosine of alpha plus beta would be, right? So cosine of alpha plus beta is equal to, so cosine of alpha plus beta would be OB, right? OB adjacent over hypotenuse, which is OP. And then we can write OB as OA minus AB, right? OA minus AB over OP. And instead of writing AB, we can write RQ, right? Because we know this is a rectangle. So we can write OA minus RQ over OP. Now, what we're going to do is we're going to consider, let me scoot it down a little bit, consider triangle OQA. So OQA, okay? The measure of angle OQA is equal to, so OQA would have to be 90, right? 90 minus alpha. Okay, let me make that a little bit nicer. So 90 minus alpha. Because this angle plus this angle has to be 90, of course, because this one is 90 here, right? So alpha plus 90 minus alpha, right, gives us 90 degrees. So this angle here has to be 90 minus alpha. So that means this angle here, right, this angle here must be alpha. Because we know RQA, right, is 90 degrees, right? So we know alpha plus 90 minus alpha is 90. So that means RQO is alpha, right? So OQA, of course, is 90 minus alpha, which implies that the measure of angle RQO is equal to alpha, right? And of course, since PQ is perpendicular to OQ, that means PQR here must be, right there, must be 90 minus alpha again. Because alpha plus 90 minus alpha would give me that 90 that's required here, right? So this implies that the measure of angle, so PQR, right? PQR is equal to 90 minus alpha. And of course, if this is 90 minus alpha, that means this angle here must be alpha, because alpha plus 90 minus alpha would give me 90, which is required for the sum of these two. So that implies that the measure of angle RPQ, right, RPQ is equal to alpha. Okay? So now what I'm going to look at, I'm going to try to find this PR, right? But now I can work with triangle PRQ, right? So I know cosine of alpha would be PR over PQ, right? So cosine of alpha is equal to PR over PQ, right? PR over PQ. And of course, I want to solve for PR. So what I can do is multiply both sides by PQ to get PQ cosine alpha is equal to PR. So I found my PR for this formula. Now I need to find my AQ, right? So AQ. So I know sine of alpha is equal to AQ over OQ, right? So let me go down here. So I know sine of alpha is equal to AQ over OQ. Of course, I want to solve for AQ, so I can multiply both sides by OQ to get OQ sine of alpha is equal to AQ. So now I have PR and AQ. So let's go ahead and revisit sine of alpha plus beta. So this means sine of alpha plus beta is equal to PR plus AQ over OP. We know PR is PQ cosine alpha. And we know AQ is OQ sine alpha all over OP. And we can rewrite this as PQ over OP times cosine alpha plus OQ over OP sine alpha, right? And I have the picture down here. So now let's look at what PQ, right, over OP is, right? We can see that that's sine of beta, right? We can see that sine of beta is equal to PQ over OP. And we can see that cosine of beta is equal to OQ over OP, right? And that's exactly what we have here. So let's go ahead and scoot down. So now we know that sine of alpha plus beta is equal to, so we got PQ over OP cosine alpha plus OQ over OP let me make that Q a little bit nicer. OQ over OP sine alpha. Right? And now we know this is equal to sine beta cosine alpha plus cosine beta sine alpha. And using the commutative property of addition and of multiplication, we can rewrite this as sine of alpha cosine of beta plus cosine alpha sine beta, right? So we have sine of alpha plus beta is equal to this, which is exactly what we're looking for. Sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. Now we're going to look for cosine of alpha plus beta. All right, so we have cosine alpha plus beta equals OA minus RQ. So we're going to try to find OA and RQ. Right? So OA, right? So OA looks like we can do cosine of alpha is equal to OA over OQ, right? So cosine of alpha is equal to OA over OQ, right? Remember, we want to find OA. So we're going to multiply both sides by OQ to get OQ cosine alpha is equal to OA. Now we also want to find RQ. So RQ. So we know sine of alpha is going to be RQ over PQ, right? So sine of alpha is going to be equal to RQ over PQ. Of course, we want to solve for RQ, so we multiply both sides by PQ to get PQ sine alpha is equal to RQ. So now, remember, I had cosine of alpha plus beta is equal to, so cosine of alpha plus beta, OA minus RQ over OP. Okay, and now we know what OA is. It's OQ cosine alpha minus, and RQ is PQ sine alpha over OP. And this is equal to, we can write this as OQ over OP cosine alpha minus PQ over OP sine alpha. And now let's look at what OQ over OP is, right? OQ over OP. That looks like cosine of beta, right? OQ over OP. So cosine of beta is equal to OQ over OP. And so PQ over OP, PQ over OP is sine of beta, right? Sine of beta is equal to PQ over OP. So now we have cosine of alpha plus beta is equal to OQ over OP is cosine beta, okay? Cosine alpha minus sine beta sine alpha. And then, of course, we can rewrite this, okay? We can rewrite this as cosine alpha cosine beta minus sine alpha sine beta. So we have cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And that is exactly what we were looking for. So we have proven the sum formulas for sines and cosines.